Hello everyone. Here in this video, I would like to show you how we would be able to load the data we measured for the step response and how we could find the time constant using the graph and by using the data cursors. Okay, so like I showed you before in the previous video for lab number 5, to load your data, all you need to do is drag and drop this to your workspace, just like this. And then there's going to be a pop-up showing up. And here you'll need to select only the area that has numbers there. And don't forget to convert this into numeric matrix and then import it. Then you'll see this new variable that is being stored in this workspace. And once you double click that, you should be able to see it has 2 columns, just like what you expected. The first one is the time, and the second one is the voltage we measure, right? And then, or if you can also try by right-clicking the file and then hitting this import data, and the same window will pop up. So you can do in either ways. So once we have these loaded in workspace, then we would like to plot those things. So we know that the first column is time. So it is data step response, and everything in the first column is going to be your time. Okay, and by putting this semicolon to the end, it just makes MATLAB not to plot all the things on this command window. Okay, so that's our time. And the second column was the variable, right? The value. So we just slightly update this, like everything. This column means everything, right? Everything in the second column is going to be stored as a value. Okay, so once we run these two, then these two variables will pop up like time and value. Here we would like to open a blank figure just like this. So there's a blank figure popping up. And we can also plot on top of that blank figure time versus value. So the horizontal axis is going to be the time, vertical is going to be value. And if you want to do some cosmetics, of course, X label, and you need to have these 2 apostrophes, and anything you type in between these apostrophes is going to be displayed. So time, and this is in seconds, I believe. So on top of this blank figure, let's plot that thing. So now it shows up here. And then if you want to put a label down here, X label, you'll see there's an X label there. All right. Okay, so the next step is we would like to identify the time constant by using this data tip or data cursor. By the way, I'm using 2018 version, so all the icons are up here, but in the most recent one that is installed on the computers in our labs, they should have those on top here. So, and not instead of having those there. So if you hover your cursor around on top of this figure, then suddenly something will pop up there, and then you can select all the zoom in and out and all these things. Okay, so first thing I would like to do is I would like to zoom into any of these plots there. Okay, and it's beautiful. It's, see, it's from the bottom, it is rising up, and then it's getting saturated just like that. Okay, so from here, I'm trying to using this data cursor, which shows the corresponding values of each point. So if you click here and there, you can see the values at that point. Okay, so here is the point that we're interested in first, because the curve rises up from there and then it goes up and then gets saturated over there. Okay, so I'm interested in knowing this point, and I'm also interested in knowing the point over there. Right, so in this case, having multiple cursors, data tips are going to be easier. So I would hit Alt key and then press Alt and click. Alt and click like that. So it creates more data tips for us. If you don't press the Alt button, then the last cursor just moves along here and there. Okay, so I'm interested in this starting point and also when it stops. So it starts from -7006 in my case, and then it gets saturated up to 4.224 volts. And the corresponding time when it starts is 0.0513, which is around here. And well, this time here is not that important. And what we're actually looking for is, if I just draw something like that, I just show you line. So we're kind of interested in something like this, right? The time, insert a line, just to visually show. Assume this here is 100%. You want to find when it rises up for 63%, and the corresponding time here and there, the difference is going to be your time constant tau, right? So we first need to identify what is the total difference. So it starts from -706 and it goes up to 4.224. So the value should be 4.224 plus 7.06, right? And let's call that as our total. Total is going to be 11.23, all right? So from here to there is 11.23. And this here is going to be 63% out of that. So 0.63 times total. It's going to be about 7.074. Just like that. Okay. So this value here from here to there is going to be what? 7.0749. On the other hand, it starts from -7006. So the actual value at this point should be, we should subtract 7.0749, right? Oh, no, it starts from 7.006. Right? So the actual value of this point here should be 0.0689, all right? Yeah, so that's the value we're looking for. So what we would like to do is we would like to move around this data tip until the vertical value hits 0.0689. So this, it's going to be between these 2 points. It's because here is -0.103, and this one here is 0.238783, right? So the actual value should be somewhere around here, just roughly speaking, okay? However, due to the resolution, we were not able to pinpoint that one. Probably in your data set, you might be able to pinpoint a better one because this one was having a little bit lower sampling frequency, but for your lab, it was increased up to 20 kilohertz or 40 kilohertz. So you should have a better resolution. Anyway, so I would like to find the closest one to this 0.0689, which should be around here. It's a negative, but that's closer. So the time here is 0.05141, and the time it started was 0.0513. So the difference between those two here is going to be your tau. Okay, so that way you can identify those tau values from your experiment. So, and then you would like to move on to the next curve, that is here, and to your next curve over there. See, so you measure these 10 times and then find the mean and standard deviation value so that you can discuss the uncertainty in your report. All right. Okay. That's it for today, and I hope this helps, and I'll see you guys soon. Thanks.